In this video, we'll explore variations of histograms, specifically delving into relative distributions and cumulative distributions. In a previous section, we examined the ratings of 10 sushi restaurants using a histogram to illustrate a frequency distribution. Our sample size, denoted by n, was 10. To gain a deeper understanding, we introduced the concept of a relative distribution. By dividing the counts on the y-axis by the sample size, we obtain the probabilities, ensuring that the total sum equals 100%. For instance, the probability of obtaining a number from the first bucket in our dataset is 30%. Expanding this, if we want the probability of numbers from buckets 1 or 2, basically the probability of selecting a restaurant with an average review between 1 and 3, we sum the probabilities of the first two columns, resulting in 70%. Continuing this pattern, the cumulative probability for the first 3 buckets is 90, and for all 4 buckets, it's 100%. Another approach to extract probabilities within a range is through a cumulative distribution. In this graph, we have condensed the original relative distribution, starting with the first slot mirroring the relative distribution value. Subsequent slots represent cumulative sums. For instance, the second slot contains the sum of the first two values. 30% plus 40% equals 70%. This cumulative pattern continues for the next and until the last slot, summing all the values to reach 100%. The cumulative distribution is characterized by a continuous increment in values. If asked about the probability of visiting a sushi restaurant with a review of less than 3 points, we can refer to the graph and assess the height of the bar on the second bucket, which corresponds to a cumulative probability of 70%.